belletjes, ik vertel het je met mijn money shit. Hang niet met die belletjes, het is welletjes, want ik drop die hits. Gun me werk, 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 ik kom hard als drugs. En als ik harder werk, dan ontploft de club.
Hello everyone, my name is Loab, and welcome back to the third lecture on this game hacking journey. In today's lecture we are finally ready to start getting used to the tools like Cheat Engine, Reclass and x64dbg. These tools will be important in our game hacking journey, as we need these tools to find all the information we need in order to write our cheats. So without any further bullshit, let's head to cheatengine.org. This is the only place where I recommend you to get a copy of Cheat Engine from. We can get Cheat Engine by clicking on the big green download button. If your antivirus is flagging Cheat Engine as a virus, then please make sure to turn off your antivirus and turn off threat protection of Windows. You don't have to be worried though, Cheat Engine is not a virus. Our computer confuses Cheat Engine as a virus because it gives us the ability to modify other programs on our computer, which is kinda like a virus can do as well. However, the difference here is that we have all the control over Cheat Engine. This means it's totally safe as long as you do not mess with important files yourself. Once it's downloaded, we can start the installation process. But I do want to note that you must be careful of all the advertisements in the installer. Click on OK. And now we have to be careful, so click on Next. And make sure to decline all the optional offers that come with Cheat Engine. Click on Decline, Decline, Decline. And it's going to install the latest version of Cheat Engine on your computer. Once it's finished, you can just click on Finish. And there we have Cheat Engine. It's installed now. The last thing I recommend you to do is to right click on Cheat Engine. Click on More Options if you're on Windows 11. And if you're on Windows 10, click on Properties. Go over to Compatibility and make sure you run this program as an administrator. Just click the box, click on Apply and click on OK. And that's it. Cheat Engine is now installed and we are ready to use it. Now it's time to go to the description of this video and install Reclass by clicking on reclass.net.rar. Be sure you have WinRAR or 7-zip installed before you download Reclass. Once it's done, open up the folder of the download. We then go to our desktop and we make a new folder. And we call that Reclass. We want to drag in this WinRAR folder into Reclass. Double click the new folder. Then open up this WinRAR folder. And what I like to do is just select everything and drag it in there. That's it. It's now installed. You can open up x64 and x86 and you can find the .NET exe file here. What I recommend you to do, just like me, is right click, click on More Options. Or if you're on Windows 10, instantly click on Create New Shortcut. And do that for each version, x64 and x86. And then I recommend dragging these shortcuts to your desktop like so. We're going to be using both versions for different games, so I recommend you to do it like this, just like I have with Cheat Engine, EDA Pro and x64dbg. Now the last thing we have to download is x64dbg from x64dbg.com. This is also the only website I recommend you to get it from. You can find a link in the description down below. Click on this download button and then download the latest version once we get to this sourceforge.net website. Once the download is finished, you can click on the folder to open up your downloads folder. And then it's time to make another folder on your desktop. Let's call it x64 debug or debugger, doesn't really matter. And just drag in the snapshot in there. Open up the folder. Then open up the zip file. Take all the context that's in there, right click and copy. Go one back and just paste it in there. Or you can right click and extract it, of course. Okay, now you can open up the release folder. And here we also have two versions for 32-bit and 64-bit. Keep in mind that 32-bit is the same as x86. Alright, so now that we've downloaded all the files we need, it's time to open up Cheat Engine. You can see that I've got Cheat Engine 64-bit and Cheat Engine 32-bit. You've got these ones in your folders as well. However, on your desktop you will probably just have the normal Cheat Engine. That's, I guess, compatible for both versions. You can just open that, but I'm going to open up Cheat Engine 32-bit. Now that we're in Cheat Engine, we are ready to click on Edit and click on Settings. Now we first have to change a few settings. The first thing is we go to Debugger Options. And I recommend you to use VEH Debugger. This one seems to work the best for me. The Windows debugger sometimes messes up for me, so I recommend you to switch to VEH Debugger. Next up we go to Scan Settings. And we want to make sure that all of these checkboxes are checked. Then we're heading to Hotkeys, and I recommend you to set hotkeys for the following options. Pause the selected process, SpeedEgg plus and minus, and next scan for increased value, decreased value, changed value and unchanged value. I recommend you to use the numbers on your numpad if you have those. Once we're done here, we can go over to extra custom types. And if you're planning on hacking emulated games, then I recommend you to turn these on. We can go to scan settings for the last time, and we can turn on pause while scanning on by default. This is kind of personal preference, but for some games it's very useful to use this feature. However, I like to keep it off for now. This option is also kind of personal preference. If you want to store temporary scan files, you can pick a folder and then it will store all these files in there. And again, if you plan on using Cheat Engine with an emulator, then I recommend you to turn on these checkboxes as well. Alright, and that's it. We can now click on OK and we've set up Cheat Engine. Alright everybody, we are now finally ready to get our hands dirty on some reverse engineering stuff. We're going to be using tools like Cheat Engine, x64dbg and Reclass in this video. Also, we're going to be using these tools to find some information we need before we scan. But before we get to that, actually, you want to go to Google and just make sure you've got the same version of AssaultCube installed as I do. You can find this link to the GitHub of AssaultCube in the description down below. And then you want to make sure to download AssaultCube 1.2.0.2. Click on here, scroll down, and then you can download AssaultCube for Windows, Mac or Linux. Okay everyone, so what is the first thing we have to do when we're going to make a cheat? Well, if we're going to reverse, the first thing we have to do is find out whether our game is 32-bit or 64-bit. And in order to do that, we need one of these tools here. Both tools will be in the description down below. I'm going to show you how to use both tools, but first we have to find the executable file of the game. So let's just right click on AssaultCube, click on More Options if you're on Windows 11, and if you're on Windows 10 you can instantly click on Properties. Then we can find this path right over here. This is where our game is installed, of course. And the first clue that gives us that this is a 32-bit game is that it's installed on the program files x86. But let's just continue. So copy this path. I'm going to open up my folders. And in here I'm going to paste this path. And this is another clue that gives us the information that it's a 32-bit game. It's got a folder bin_win32, which stands for Windows 32-bit, of course. Let's just open up this folder, and then we found the executable for the game. Let's drag both of these in these tools here. And let's start with Detected Easy. We can see the mode is 32-bit, so we know for sure now this game is 32-bit. And for the exe info PE, we can see image is 32-bit executable. Okay, so we now know the game is 32-bit and not 64-bit. But why do we need this information? Well, the reason for that is because we have to select the right version when we're going to reverse engineer. If we're going to be using Cheat Engine 64-bit on a 32-bit game, it's not going to be compatible and you'll be very confused. It might not even work, okay? So be sure which architecture is being used by the game. So we know it's 32-bit, so we use 32-bit for cheat engine. We use x86 for Reclass because x86 is the same as 32-bit. And x32dbg for x64dbg, okay? So this version here. So let's close down this here and let's start up the game. And let's drag that to the right. And let's also open up Cheat Engine 32-bit. Okay, so once we've done that, let's go to the game and quickly start a single player match just to get out of this demo match. And I recommend going to the map AC_Deuce. I think this is the best map to reverse engineering because we can find nades very easily. And it's a pretty small map as well, so you can find enemies as well very easily. So let's firstly attach Cheat Engine to the game. And I also quickly want to show you what we're going to make today. Alright, so right here I've got a cheat table which I've made a while ago. I can open up these headers and we will start seeing a lot of pointers. And all this information you see here can be used to create a cheat. And two very important ones are this local player and this entity list. But what are those? Well, first I'm going to attach to the game. Just like so. And yes, I want to keep the list. So yeah, what are the local player and the entity list? Well, a local player is a container, or you could name it a list. And this list represents the player-controlled character within a game. In this list, we can find information about the current state of our own player, like our health, our position, our orientation, and many other things that we may want to use in our cheat. And the entity list is a container with entity objects. It's got a collection of all the entities that are present in the game. Think about enemies, NPCs, items, terrain, etc. The local player and the entity list are not exactly the same thing, but they do share some similar aspects. For example, the local player only holds information about your own character. However, the entity list will also contain information about your own character, but also that of all the enemies. The local player does not hold any health of an enemy, for example. But why do we need to find the local player and the entity list? It's actually very simple. If we want to make a god mode, we have to specify which value of a memory address we want to modify. Let's say we want to change the health. We would need to define a path in our code that leads us to the memory address of health. We've learned in the previous video that in order to achieve this, we need a base address plus offsets. To find the health, we would have to take the module base address of AC client plus a relative offset, which in this case will be the local player, and then we dereference the pointer. And by doing this, we are now in the local player object. If we then move a specific distance in that object, let's say we move like 4 bytes downwards, we may arrive at the memory address of the health. So this distance, 4 bytes, will be the offset. So we can see here why the local player is so important. We always make pointers to anything we want to hack, like health. Same works for the entity list. However, here you can also access information of enemies, like coordinates, which we can use to create an ESP. Alright, but how do we actually find the local player and the entity list? Well, in Assault Cube it's actually pretty simple. Just keep in mind that every game is different, so you will have to learn how to reverse engineer yourself. The process of finding anything you need is pretty simple. You create a hypothesis, and you test your hypothesis, and then you see if it worked. If it didn't work, you create a new hypothesis, and try it with a different method until you find your solution. This is what's called trial and error, and you will have to deal with this a lot in reverse engineering. It's not simple, it requires a lot of patience, so do not be afraid if you do not understand anything in this video with the first try. So let's try this trial and error method. Step 1 is creating a hypothesis. So we are trying to find the local player. Well, how do we find that? And now it comes. I think I can find the local player by scanning for something from which I think might be the local player. So let's say health. So I've closed the previous example, and I'm going to open up Cheat Engine for the 32-bit version, of course. And what we're going to do is attach to the process. Okay, so what I'm going to do is I'm going to scan for our health. And actually, instead of 2 bytes, let's set it to float. Okay, and then let's do our scan. So, okay, we know our health is currently at 100. So we type in 100. And we know that the health variable, like a value, is exactly 100. So we can pick exact value. For the value type, we are not actually sure which one is the right one, because every game developer may use a different variable data type. So let's say we're going to guess that it's float, and we're going to do our first scan. So we've got a lot of results, so we want to narrow down this list. And just like I've done in the introduction, you can throw a nade and damage yourself. And then we can find in this list for any values that have changed to 39. And we do next scan. Okay, and it seems like we got one address. Let's just damage ourselves again, just a little bit. And we're dead. I fucked up. Let's respawn. Okay, our health is now 100. So let's scan for 100 and do next scan. And it seems like we have not found our health. Well, that's what I mean. We failed. It didn't work. We could not find the health address. So then we would have to create a new hypothesis. Like, let's say, okay, well, float didn't work. Well, maybe it's 4 bytes then. And 4 bytes means it's a 4-byte integer. 4 bytes is an integer. So let's try it again. Our health is 100. Let's do a scan. Take a grenade and damage ourselves. Scan for 34. Next scan. And maybe this is the right one. 999. Well, yes, it did change. Let's see if we are immortal by throwing a nade directly under us. And yes, we are immortal. So that's what I mean with creating a hypothesis and testing it out and seeing if it worked. This is what your reverse engineering journey will be all the time. It's just trying and seeing if things work, okay? So we have now found our health address, and that's good. It's not as easy as it seems sometimes, okay? Okay, so now that we have our health address, we are ready to do some more in order to find the local player. But how do we actually find the local player? And there are different ways of doing that, of course. And I'm going to show you 2 ways of doing this today, in both Cheat Engine and X32DBG. But let's just stay on Cheat Engine for now, and then later we swap to X32DBG. In the introduction, I demonstrated that the memory address that we've got right here becomes invalid after we restart the game. This happens because the game stores health at a different address each time when we restart. And to fix this problem, I showed you how to use pointer scans. In the introduction, these pointers worked well even after restarting the game. However, I mentioned the importance of choosing the most logical pointer. Now you might wonder, how do we determine the most logical pointer? Well, if we pick a pointer that follows the game's code, we're choosing the most logical one. So how do we follow the game's code? Well, what we can do is take a look at the code instruction that happens when the game uses the health address. If I right-click this address, we can see 2 options. Find out what accesses this address and find out what writes to this address. Accesses means that Cheat Engine will find instructions that read the value of a memory address. But it will also find instructions that actually change the value in the memory address, aka what writes to this address. The option find out what writes to this address will only find instructions that write to the address, so only what changes the value. So find out what accesses this address will find instructions that read and write, and find out what writes to this address will only find instructions that write to the address. So let's pick find out what accesses this address. And let's click on yes, we want to attach the debugger of Cheat Engine to the game. And we have now actually found game code that has to do with this health address. And we can see every single tick like these two instructions are getting called. So this is very likely a read instruction. We're probably just taking the value that's stored in this address and we're using it somewhere, but we're not actually writing here. Okay, so now let's take a grenade and let's take some damage again. And we now have two new instructions here. And we can see, okay, these instructions were called for only one tick. So this could be a clear indication that these two are writing instructions. And I do understand that many of you will be scared because what the hell is this? Well, this is game code and I understand that it's intimidating for new game hackers. I felt exactly the same when I got started, and please do not worry too much about this for now. We will learn more about this in future lectures and I will make sure you won't be as confused as you may be right now. But just for the sake of showing you how to find the most logical pointer, I will explain what's going on here. Let's just click on stop because we don't need this to keep counting up. And if we just take a look at the game code, we can see that these three instructions here are pretty similar to each other. We've got EBX, ESI and ESI. These are called registers. And we've got F8 and F8. These are offsets. If you have a different version of Assault Cube, this may be different. So keep that in mind. So Loab, what is a register? And well, you probably already know what an offset is, but what is a register? A register is used to store and manipulate data during the execution of machine instructions. We will learn all about registers in future lectures. Just keep in mind that there are different registers and each has their own different purposes. But basically, we've got these three instructions here that are pretty much the same, and then we have got a different one with a different offset. But Loab, which offset is the right one? Well, this is exactly what I mean with trial and error. We have to test it out and see if it worked. If it didn't work, we try something else. And just to keep it simple for you, I know that F8 is the right offset for our health address. This instruction you see here means compare 0 with the value stored at ESI plus F8. ESI plus F8 is our health address, so I think that ESI is the local player and F8 is the distance we have to move in memory from the starting point local player in order to arrive at our health address. So ESI is the local player and F8 is the health offset. Now we can scroll down and take ESI. You can copy this address here and you can click on close, and we can click on add address manually and paste in the address here and click on OK. And we can call this one player object address. So what is an object? Well, an object is an instance of a class, and a class is a blueprint for creating objects. If you do not know anything about classes and objects, you may want to learn more about C++. But this player object address represents an instance of a player class in the game's code. If you double click the address here in player object address and copy it, you can then open up memory view, and we can use a specific tool here to take a look at that structure of the player object address. So let's click on tools, dissect data structures, and right here you want to paste in the address that we've just copied, and then you click on structures. We define a new structure and you can call this, well, player end for example. And right now we can see a list of all the variables that start at that address. So basically all this information here is part of the local player class. All these variables have a data type, and these data types are guessed by Cheat Engine. For example, here we can see two decimal numbers. Maybe if we go up, it's different. Yeah, we see two decimal numbers. This doesn't seem to be a decimal number. We can see more decimal numbers here. You can find 16, 333, whatever. The auto guessing feature of Cheat Engine is pretty cool. However, it's not always perfect. We can use tools like Reclass to get a more advanced version of this dissect data struct tool, basically. More on that later though. We're just gonna continue on Cheat Engine for now. So we can see that quite a lot of information can be found here. You can see that we've got 19 bullets right now, so let's see if we can maybe find it in this local player. $15 bullets, maybe go more down. 14 bullets, and as we can see right here, you can see that that is our ammo. And we can see all the way on the left that the offset for ammo is 150. So the relative offset from the local player is 150. So local player plus 150 will lead us to the ammo. So let's remember this offset 150 here. And let's minimize this. We can close out of that. We can click on add address manually. And then in here we paste in our player object address. And then plus 150 will give us our ammo. So let's test it out, see if it works perfectly fine. 1337, and there you go. Well, this is great and it works perfectly fine. Video overwrite? Well, not exactly. This works fine right now, but once I restart the game, it won't work anymore. The player object address is created dynamically in memory to be efficient, so we must find a pointer to our player object address in order to make this work every time when we restart the game. So let's find that one right now. We are going to take the address of our player object address again, just like so, copy that, and we will do a new scan. And then we click on this hexadecimal checkbox and paste in the address. And the reason why we use hex is because this is an address and an address is a hexadecimal number. Okay, so let's click on first scan. And this may look very scary. What is all of this? Well, these are all just variables that hold a memory address as a value. And you may remember from the previous video that variables that hold an address as a value is just a pointer. So everything we see in the scan results here are basically all pointers. The green ones we see right here are static pointers. This is exactly what we are looking for, because when we restart the game, these green static pointers will always lead to the right player object address. All the white ones you see here, well, these are dynamic. We do not need these in this case, because we already have these green pointers. So let's click the first one and shift click the last one and click on this arrow to add all of these to our table. All of these pointers are probably going to work, but which one is the best one to pick? If you double click this address, we can see that it has a module base, acclient.exe, and this module base gets loaded into memory when we double click the game, and it has a relative offset. And this relative offset is what we're looking for, because that's going to be local player. However, we've got 3 of them. So which one is the most logical one to pick? Well, firstly, all of these pointers are very likely to work. They all point to the player object address, which is good. However, you will be spending a long time on reverse engineering the game. So maybe after a week, one of these offsets may no longer work, and maybe this one, for example, still works, while this one, for example, doesn't. That means that this pointer right here would be more reliable. So yeah, we can pretty much use any of these 3 pointers. However, I recommend using this one, where 10 F4 F4 is the relative offset. And the reason why I recommend this one is because if you did some more reverse engineering, you would find out that the entity list is actually only 4 bytes away from this relative offset. So the entity list, if I copy this one here and click cancel, and I remove these 2 here, or actually no, let's not remove them first, let's just drag them all the way to the top and call this one local player. Okay, so again, we take this local player and we click add address manually, and I'm going to paste it in here. If I add 4 more bytes to this relative offset, it becomes 10 F4 F8. And in AssaultCube, this is actually the entity list. So that means if that's the entity list, that local player and the entity list are directly under each other in memory. So that's why this one is the most logical one, because it's one step above the entity list. And this one here, well, of course, it's probably going to work, but it's very far away from the entity list. I just want to make clear that this is a logical pointer to use. A good game developer would use the most logical one, but it's not wrong to use this one or this one, as long as it works reliably. And I understand that you may be completely lost right now. It's pretty confusing, I know. If you have any questions, you can always ask me on Discord. It will just be easier once you have more experience in reverse engineering. So yes, we can now remove these and let's organize our cheat table for a bit, okay? So let's right click here and create a new header, and let's call this one structures or data structures, whatever. I just call them structures, and we don't want to add address support. And let's click on this one, let's right click, and let's just give it a nice color to make it a bit more cleaner. And let's drag it all the way to the top. And now we want to take local player, and we want to drag it so that the white line you see here is in the middle of structures. And the same for entity list. And now let's take these two by either shift clicking or control clicking on both, right click, and then let's change the color to this here. Okay, this looks much cleaner and it's gonna make you look like a pro, you know? Okay, so we have found the entity list and the local player. Well, actually we found the local player. I already knew what the entity list is. If you want to find the entity list yourself, what you could try is you could scan for an unknown initial value, and you could damage an enemy and then scan for a decreased value, and then damage him again and scan for another decreased value, and keep going until you have the health address of the enemy, and then do the same process as we did before to find the entity list. But what we're going to do now is actually pretty cool. Let's first start another single player match, because we are currently in a demo match, and AC dues. Alright. And I'm going to show you how to find the local player in X32DBG. This one here. So let's double click that. And what we need is our health value first, okay? So let's scan for 100. And let's do a new scan. Make sure we are on 4 bytes. Turn off the hexadecimal check. 100 and first scan. Let's take some damage. Just like so. 6-3. Next scan. Sorry. And okay, we've got our health here. So let's take the address of our health and open up X32DBG. And we're going to click on File, Attach, and then double click AC Client. Or click on AC Client and then Attach. It doesn't really matter. I just double click. And this will look very scary as well, because this is even more game code. And all this information here, this weird dumps. Well, basically what's going on here, this is just the assembly code. These here are registers, and these here are dumps. So this is memory in hexadecimal. That's basically what's going on. We can click on symbols and double click on AC client, and that will make us jump to the assembly code that has to do with AssaultCube. Okay, so what we're going to do now is we're going to right click in this dump 1 and we click on go to expression, and it will ask us for a address. So just Ctrl V, paste in the address from health and click on OK. And that will bring us right here. And we can see that the hexadecimal value of this address is 3F. If I take my calculator and I make sure I'm in programmer mode, and go to hexadecimal and go type in 3F, we can see the decimal number is exactly the same as our health. 3F is 63 in our game as health. So that's a way of checking that we are at the right address. So what we're going to do now is we're going to do exactly the same as we did in Cheat Engine. You right click on that value, you go to breakpoint, and here we have the same options. Find out what accesses this address and find out what writes to this address. Only we have got a few more options, like we can find out whether a byte is writing to an address, a word or a D word. We are going to go to access and pick D word, and D word stands for double word. And D word is typically like 32 bits or 4 bytes in size. So D word is just a 32-bit integer. So let's click on D word, and you can see that the game has paused, which is perfectly fine. We just have to click on this little arrow here to continue in the game code. So currently we are at the instruction like you've seen in Cheat Engine, where it was like every tick it was doing an instruction. That's what's going on right now. That's where we are in the code. And let's just click on this button here to continue, 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 continue. Okay, and it seems like it's going here. 19.4. 19.4. So these are the two instructions that we've seen earlier before. These reading instructions. And we can also see it's moving ESI plus F8. So that might be what we're looking for. ESI plus F8. So we can take ESI here as well, and we can like test it out. However, we can also see, okay, so that's the difference here. We see it's moving ESI plus F8 into EAX. It's storing this value in EAX. And in Cheat Engine, it was comparing the health address to 0. So this is a different instructions, but there are obviously, as you can see here, different ways of getting to the local player. So in this case, you can also select ESI for like right here. See if you can double click it and then you can copy it. Click on OK. You can go to Cheat Engine then. You can do a new scan. You can paste in the address of ESI. You can make sure that it's on hexadecimal. Click on first scan again, and you can then see we get the same pointers again. So there's different ways of doing it. You can use Cheat Engine tools, but you can also use X32DBG. But just keep in mind that in X32DBG and, for example, EDA Pro, we can do a lot more than we can do in Cheat Engine. So that's why it's useful to at least get started with one of them. I recommend X64DBG for beginners. If you're more experienced, then switch over to EDA Pro. And you can find a correct version in my Discord server, so I recommend joining. Okay, so now that we know how to find our local player, let's just make sure we don't crash. So click on breakpoints, click here, right click, and remove this breakpoint. And then just click on play, and let's see if we can play. Well, yes, I can play, but apparently I don't have audio. And I don't know why. Whatever, I'm just going to restart the game. Okay, let's clear that, make this empty. So, yes, this health doesn't work anymore, obviously, because it's dynamic and these are static, so they still work. Let's start a new bot match, just to get out of this demo map. And let's freeze the bots. Okay, so we are now finally ready to do some more juicy stuff with local player, okay? So you've already seen before that we're looking at the structure of the local player. But what we can actually do is we can copy this here. And then we can open up reclass.net, x86 of course, because it's a 32-bit game. And we can make this a little bit bigger. And let's click on this magnifying glass and click on AC client and attach to the process. And now we want to load the local player mod, like the module base plus the local player. We want to load in that module. So we double click on this 4000 here. You paste it in here, but don't click enter yet. What we're going to do is we're going to add these angled brackets in front of the AC client.exe. And then we add these rectangular brackets at the outer edges, like so. Once you've done that and you've made sure you're attached to the game, you can click on enter. And we can now take a look at this data structure again, just like we did in Cheat Engine. However, we get the ability to look at both floats, integer numbers, and hexadecimal numbers. So yeah, okay, we can see this is not a lot of information. So let's change that by clicking on this green icon here and then adding a lot of bytes. Let's say 4096. And we can now see a lot more information, okay? And we can see that, well, these first three here, we see on the very left, we have the decimal numbers. And it looks like coordinates maybe. If we move around, okay, let's say we jump only. Yeah, we see the third one is changing. So that seems to be coordinates. If we move forward, like one, yeah, it's changing as well. So if we click on the first one here and we click on fact3, we make these three offsets a factor 3. So we can also change that here, and we can name this one maybe, well, you can name it coordinates, but I know that these three here are your head coordinates and not your actual coordinates. Head, chords, whatever. And the reason for that is if we, okay, let's just search for our actual coordinates, and then you will see what I mean. So let's just move around and see if we can see anything that might be our coordinates. And it seems like this and like these three are our x, y, and z coordinates. Because if I move up, you can see it's now increased to 8. And if I move down, it's 4, 3, 2, 1. And if I jump, see? So these three are actually our coordinates. So let's make another vector 3. Oops, my bad, I fucked up. These are not vector 3. Okay, whatever. This one is the right one. This is our coordinates. And you can see here, if we compare the two, 119.683 is correct. It's exactly the same. See? Then we have 115.231 and 115.231. These are exactly the same. However, the difference sits at the z coordinate. This one is at 0, and this one is 4.5 units up or something. See? So that's why this is our coordinates of our feet, and this one is our head position, like the camera position. It's 4.5 units up. So we know that these are our head coordinates and these are our feet coordinates, basically. Let's see if we can find our health. So we have 100 now, so let's take some damage. And perhaps we can find it in here. And we saw something change here. 37. Well, that's probably our health. And it's now on some invalid number. Never mind, I didn't see, I was looking at the wrong one. 100. And that seems to be the right one. Let's try it again. Damage ourselves. 7.4. So we can see 7.4 at offset F8. That's our health. So select this one, and we know it's a uint32. And if you remember from the previous video, uint stands for unsigned integer. And this one, 32, says it's 32 bits. Okay. So click on here. Oh, you can also see here that uint32 is a D word. Okay. So 16 bits is a word, 8 bits is a byte, and then 64 is a keyword. So let's name this one health. And let's see if we can find ammo. We have currently 19 bullets, so let's stare at Reclass and just shoot and see if we see anything change. Well, I don't see anything that could be our ammo, so let's scroll down and see if we can find it here. Okay. Okay, I see two very interesting things. I see this here, which is holding the value of our ammo, but I also see this here. Every time when I shoot, my ammo decreases, but the second one on offset 1A0 is increased. So that means that, well, these both are probably 4 bytes integer. So let's click on uint32. And then this one is our ammo. And this one is our times shot. It holds how many times I've shot with my gun. So if I shoot 5 more times, I guess it's on 21. And as you can see, it's on 21 now. So we found the address for times shot. Maybe we can also find our armor, for example. So let's fly up here. You can use E to fly, of course. And we've got 50. So let's see. Okay, here I see 50. Let's see if armor comes back. Can I take this armor or not? Oh, no, I can't, apparently, I guess. So if you can't test it like this, let's just remember the offset, F8. And we go to cheat engine. We double click on the local player address. You copy this here. Click on cancel, add address manually. Click on pointer. And then you paste in your local player here. And then the offset FC for armor, yeah. And click on OK. Let's change that to health. No, sorry, armor. It's getting late, sorry guys. Let's not forget to attach to Assault Cube, of course. Yes, I want to keep the list. And yes, it's holding 50, so let's change that to like 100 and see, or 1000. And it did work, so we know that FC is, well, it's 4 bytes, of course, and it's our armor. You can find a lot of information from here, as you can see. It's very interesting. Okay, so let's say we perhaps want to find our name. Well, we can look in this green area here. And just in case you want the same color theme as I do, I will leave a screenshot in the screen right now, so you can copy them. If you have different colors, just know that the third one here, that's going to be what you're looking for. And if we scroll down, we might actually find our name. And my name right now in game is Loab. But let's see if we can find Loab. And it seems like on offset 224, we've got my name, but it's weird because the first byte is a dot, and that means that it is 0 bytes. And then the L is not on offset 224, but L is actually on 225. So that means that this is not aligned to a 4-byte address. And in order to fix that, is we click just here, and then we click on hex 8. And we can now see that on offset 224, we got this byte 0. On 225, we have LO. And on 227A, 228B. So we click on the first letters here on 225, and we right click, and we can change the type to UTF/ASCII text. And now we can only see that we have 2 letters in our name. So let's change this to 4 by double clicking, like so. And it will correctly show our name. But what if our name has 6 characters? Well, we have to find out what the maximum amount of characters of our name is in game. So we can check that by doing name /name and then typing 1, 2, 3, 4, 5, 6, 7, 8, 9. And then an X, which represents the number 10. And then again 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we click on enter. And now we've changed the name, we can click on top and we can see that the name cuts off at 5 right to X. So that means that the name can be 15 characters max. But we have to keep in mind that we must add 1 to 15. But Loab, why do I have to do that? Well, in programming, especially when dealing with text, it's common to use an extra character for something that's called a null terminator, or also known as a null character. This null character is used to mark the end of a string in many programming languages, including C++. So if you have a string with a maximum length of 15 characters, you would need an array of 16 characters to accommodate the 15 characters of the string along with the null terminator. For example, char player name with a padding of 16 characters equals, and then John Doe, for example. So it's John Doe plus the null terminator. So let's just double click this number 4 again and let's set it to 16. And we can see now that we've got 1 all the way to 15 and we've got another spot for the null terminator. So we can change the text here to our name. And we can find a lot more. So let's see if we can maybe find some information, like if I'm jumping around, do I see something happening? Well, yes, I think I do see something. It is right here. Do you see that when I'm jumping, it's on 0, and when I stand still, it's on 265. That's very interesting. So let's just remember offset 68 for a second. And let's go in here, and let's take our local player again. Sorry, it's here. Let's close that. Add address manually. We click on pointer. Paste in the local player here, and then the offset was 68. And then I think this might be our isJumping variable. I have to attach again. Yes, I want to keep it. Okay. So let's freeze this, see what happens. Okay, yeah, this does seem to work, kind of. We're kind of in a gravity mode, as you can see. It's very weird. So yeah, we made ourselves a weird gravity hack. So that's the isJumping pointer, pretty much. So let's open up Reclass again and see if we can find more. 68, let's assign it to a uint 32 and then change that to isJumping. Alright. So we found health, we found armor, we found the ammo for this gun. And let's say we want ammo for a different gun. So we take this one and then I have to myself. Okay, so we now have 30 bullets and then this here, 148 seems like, yeah, that seems to be the right one. So this one and this one are interesting because this one is the amount of times we've shot with this gun. So let's set both to a uint and then mtp57, no, sorry, a hpd 10, I think, I can't read it, ammo, and we have AAPD times AAPD times shots. It doesn't really matter what kind of names you give it, but yeah. So you can see for each weapon the ammo is stored at a different offset as well. As you can see here, MTP ammo, it's stored at 150, and for a different gun it's on 148, but we can see it's relatively close to each other. So other guns may also be in like a range of this. We can just guess that it's pretty close to each other in memory. So let's see if we can find anything else. Maybe we can find out how many kills we've made or something. So let's say we've got 0 now, I think. And this one increased, I guess. Or was it this one? One of these two, I guess. So that might be the amount of kills we've made. that's 1. If we make 1 kill now. Got 1 kill. So apparently I had a negative number or something before and we now have 1 kill. Let's make another kill. Oh, reload. And we now have 2 kills. And it does seem like that's the right one. So let's make another kill and see if that turns to 3. If I can find an enemy. There you are. 3, and this one has turned to 3. So yeah, we set it to a uint32 variable, and then we set our frags or something. That's our amount of frags. And you can pretty much do the same as devs as well. So what happened? Oh, the game has ended. So then I think that this is our devs. Yeah, it just has reset, so that might be correct. Start a new pod match. Okay, so let's die. Grab ourselves a nade. And it does seem like 1 F8 is our devs, as far as I can see. And we can try that out. We can try 1 F8 for a local player. So let's get that back. Like so. 1 F8. Let's click on OK. And let's change the variable to the value to 200. And no, that's not the right one. So this is not usable. We can just delete it. It's not. Yeah, I don't know. Maybe it's in a different one. Perhaps it's this one, 204. We can try that as well. 204. And then click on OK. Change it to I don't know, 200. And yes, it does seem like that's the right one. So this is our devs. And then we can do that in Reclass as well. We assign it to a uint32 and that's our devs. Like so. Okay, and yeah, maybe we can make some other fun hack. So let's try to find the timer of the gun so we can actually make a rapid fire. I think that's pretty fun. But let's not take this gun because it's already pretty quick. So let's try this gun. So let's die just to swap weapon. Oh my god, how did I survive that? Okay, so we've got this gun, and then let's see if we can find a timer, maybe. Don't see anything that could indicate a timer. This is pretty interesting, though. See how when we're shooting, it's 120, and when we stop, it's instantly going back to 0. And now when I'm reloading, it's on 2245. Okay. So let's remember this offset 178 and let's go to cheat engine. Let's add a pointer, our local player, and 1F8, I believe it was. Or no, 178 was. And then timer or MTP timer. And then let's see what happens if I freeze. Ooh, that gave us instant reload. That's weird. Ooh, okay. Let's quickly find the ammo offset of this gun again. What was it? Because I want to give myself infinite ammo. 150. Here. So we add 150 to this offset to give us MTP ammo. And let's set it to 9999. Okay, so what we can do now is we can try to find the instruction that adds a timer to our shooting animation. So we can do that by right-clicking and then do either what accesses or what writes to this address. So let's try writes for this example. And since this is a pointer, we have to find out what writes to the address pointed at by this pointer. And then let's shoot. And it seems like this instruction handles the timer. So let's click on show disassembler. And then we can right click this here. And we can replace it with code that does nothing. So that basically means that every time when this instruction is called, it's just replaced with nothing. So nothing will happen. So ultimately that's basically removing the timer. And let's see what happens now. And I think we're going to have a very fast rapid fire. Yeah, and you also have a lot of recoil, as you can see. So that's pretty funny. If you want to remove that feature, you can right click on the thing you've just knobbed, which means no operation, of course. And you can restore with the original code. And now we fix the rapid fire. So yeah, we can find a lot of interesting information. You can reverse the game yourself and find a lot of things. I'm just quickly going to use everything that we found here, and I'm going to make a cheat table out of that. So let's just make a new header, and let's call this one like HP. And no, we don't want address support. And I'm going to drag this one to here. And no, not to there. I want you right there. And then change color, and let's make this one like a dark green or something. And then we're going to add the health and the armor. And these are at offset F8 and FC. So we can add an address manually. We take, this is the local player. We need that one. Local player plus F8 gives us the health. And let's drag this one up with the line in the middle of HP. Let's add another one. Click pointer FC, which is our armor. And we drag that one to HP as well. And let's make these two colors green, but like a bit lighter of green. And then let's add another header and call it ammo. And no, we don't want the address support, and let's drag it up there. Let's make this one another color, like pink. And then we add these two, 148 and 150. So that's local player plus 148. And that's going to be our AAPD ammo. AAPD ammo. And we also have our MTP ammo right over here already. We can check the offset, of course. 150, that's the same. And then we also have some other interesting stuff. So create a header and let's call it like other. No, I don't want the address support. Let's make this one not set hotkeys, my bad. Change color to yellow, for example. Let's drag you to there. We already have armor. Is jumping can be put in there. Can put that in here as well, in here. And then change these two colors to a different color yellow. And change D to a different color of pink, like a light pink. And yeah, you can pretty much make yourself a very nice cheat table. And you can take a look at this list in Reclass, and you can just try to find out interesting things. And you can always just take the offset and just add that to the local player in Cheat Engine. And you can make yourself a very massive list, just like I've done right here. You can also add camera positions. The camera position X, Y, and Z coordinates, we also have those. They're right over here. So that's on offsets 4, 8, and C. So we can add those as well, just to make a complete cheat table. So let's go to like, make a new header, call this one player. No. And let's give this one a color like orange. And then let's add the offsets. Why did you move? Let's add offset 4. Let's add another one. Offset 8. And offset C. And this will be X. No, this will be the camera pos X. Camera pos Y. And camera pos Z. And you can see that these are ridiculously high numbers. That's because these are not in the right data type. These are decimal numbers and not whole numbers. So it's not integer. These 3 are float numbers. So you can click the first one and then shift click and then double shift click this one here. And we can set it to float. And now we can see that we have the right data type. So let's make these orange. And then like bright orange. Let's add each of them to player. And you can pretty much do the same thing with the coordinates. So we have 34, and then the next one is going to be 38, and then we have a 3C. That's these offsets. So that's how you make a cheat table. And in the next video, we are going to use all the information that we found here, and we're going to make our first cheat in C++. So I want to thank you for watching this video. I hope you've learned something. If you have any questions, you can ask me in the Discord. And then I'll see you in the next one. Bye bye. Oh, and actually, don't forget to save your progress by clicking on File, Save As, and then you can save your cheat table somewhere, wherever you want. And pretty much the same can be done for Reclass. Just go to File, and from there you can save it as well somewhere on your computer. All right, see ya.